We have all seen it. You are walking down a sunlit street, but your wait eyes are glued to a glowing rectangle in your hands. The entire physical world is moving around you, and you are completely checked out. Every time you want to know something about your environment, a translation, a set of directions, or the name of a building, you have to stop walking. You unlock the phone, find an app, type out a question, and scroll through the results. We carry incredible computing power in our pockets, but we lack a layer of technology that works alongside our physical environment instead of pulling us away from it. Current devices demand that the real world hit pause so we can engage with a screen. But the physical world does not wait for the user to finish scrolling. AI glasses attempt to fill this gap. To be clear, these are distinct from standard frames that just house Bluetooth speakers, and they operate differently from heavy augmented reality headsets projecting holograms. True AI glasses are connected eyewear equipped with artificial intelligence, capable of interpreting your voice, processing images, and understanding your immediate surroundings. The design encourages a behavioral shift. Your eyes stay up, your hands stay free. Instead of staring at a screen, your physical surroundings become the actual interface you interact with. Computing moves from a destination located in your pocket to a responsive lens you look through. To achieve contextual awareness, these devices hide a dense package of technology within what look like ordinary frames. It is a highly engineered tech sandwich. Built directly into the frame, tiny embedded cameras act as eyes, and discrete microphones act as ears, available to gather raw visual and audio data from your environment. That raw data is then routed to AI software. The system analyzes specific speech, images, and location signals to determine what the user is trying to accomplish in that moment. This combination of localized hardware and AI processing turns a simple wearable camera into a machine capable of understanding what it is looking at. To measure how this affects daily life, consider a test involving 10 ordinary translation and navigation tasks during a trip to Barcelona. This comparison illustrates the weight of digital friction. Using a smartphone for these tasks is a multi-step process. You stop, unlock the device, find the app, and aim the camera. These manual intermediate steps consume the majority of the interaction time. AI glasses remove those intermediate steps. Because the camera and microphone are already in position, a request becomes a single direct interaction that takes less than half the time of the phone-based equivalent. Instead of typing a query, you look at a restaurant menu and ask aloud if a dish contains meat. The glasses process the text and provide an instant audio response. You walk past a complex piece of architecture. You don't need to describe the spires into a search bar, you just look at them. Using the camera and location signals, the system identifies the landmark instantly. For a user with low vision, the device can instantly read a physical street sign or a warning notice aloud, bypassing the need for a handheld screen. The value of AI glasses is found in their ability to eliminate these dozens of micro-frictions, smoothing out the interaction between the user and their environment. Placing a computer directly onto a human face introduces new physical and social challenges. There is a constant engineering battle between providing enough processing power for AI features and keeping the battery small enough to hide in the slim arms of the frame. Then there is the issue of trust. Outward-facing cameras and always-on microphones in public spaces create privacy risks, requiring visible recording indicators that cannot be easily hidden. Finally, glasses sit on the most high-traffic area of a person's identity, their face. As past prototypes have proven, consumers reject hardware that looks overly technical, bulky, or unnatural. To survive the modern market, these devices must successfully achieve the appearance of classic frames. Today's hardware is increasingly indistinguishable from standard eyewear. The long-term survival of this technology relies on whether society accepts them socially, not just whether the underlying software functions correctly. The ideal future for AI glasses is that they remain a quiet tool. They are designed to be less intrusive and less addictive than the smartphones they complement. Their purpose is to solve genuine, small physical problems in real time, like translating a sign or guiding a repair, without requiring the user to stare at a screen. Adoption depends on the technology receding into the background, functioning as ordinary eyewear that only provides assistance when the environment requires it. AI glasses represent an environment-aware interface, a quiet assistant that removes the friction from ordinary life and then gets out of the way.